This. My name is Geraldine Alexander. I'm the chairperson of the NIC-ICTU Health and Safety Committee. And I'm joined today by Bryan Monson. He's the Deputy Chief Executive of HSENI. And Bryan has kindly agreed to deliver this session for us. You will see that the session will be recorded, and can I ask you to make sure that your audio is on mute. Hopefully at the end of the session, we'll have an opportunity for questions. So I'd ask you to leave your questions until the end of the session, and you can use the raise hand symbol to ask a question, or you can put a question in the chat facility. And as I've said, the intention is to finish no later than 11 o'clock today. So I'm going to hand over to yourself, Bryan.
Right, folks, as is always the case, my presentation which I was just about to put on the screen, has just hung. So if you bear with me for a little second till I reopen it, in the hope that this will work, fingers crossed. I have been doing so many presentations of late, and everything has worked perfectly that it is always, whenever you get onto a Zoom call or something like that, is when it goes pear-shaped on you. So bear with me a little second.
No problem, Bryan. If it doesn't work, I'm sure we can get it up anyway. So just take your time there.
Yeah. And I would begin my presentation and talk to you about various things, but to do that and to try and get this thing to work simultaneously is unfortunately beyond me, because I'm not a multitasker. Right, that might be a little bit better. So I'm now going to try and do the share screen thing and see whether you can see anything. Now, folks, can you see a slide?
Yes. Yes,
Bryan.
that's it now, Bryan.
Perfect.
Oh, thank goodness for that. I was starting to panic. Fingers crossed this continues to work. So yes, thank you very much for the opportunity to chat about ventilation. I'll start off by saying that the whole issue of ventilation and COVID has evolved and continues to evolve. And right at the start of the pandemic, we had a very different idea of how COVID spread. And as things moved on and the research was carried out, and from practical examples of what was seen on the ground, and some of that was in Northern Ireland, our opinion as to how COVID spreads has changed. And it's also fair to say that COVID itself has changed, and therefore some of the things that were relevant right at the very start have also adjusted. So the purpose of the talk then is to think about how COVID risk can be reduced through ventilation. And so a couple of definitions, and I hate to do this, folks, but just so as you're aware of them, a couple of definitions. We all know when somebody coughs or sneezes or expels air forcibly, and that can be from singing or exertion or being hit by something, for example, we all produce a mist-like cloud of particles that comes from the nose or the mouth. And the size of those particles depends on how they behave. So as you would imagine, larger droplets tend to fall to the ground. And this is where, unfortunately, when we're talking about coughing and sneezing and the like, the terminology is lovely, but what we're really talking about is big bits of snot. They tend to fall quickly. Where larger particles fall, they can wet surfaces. In other words, you get droplets on the surface. And the scientists call like fomites, and fomites we'll talk a little bit later. The larger particles, as I say, on the whole, tend not to travel more than about 2 meters, the vast majority of them, and most of them fall within less than a meter. And you can see where we got some of our social distancing guidelines early on in the pandemic. And it was thought early on in the pandemic that the vast majority of cases that were being seen were associated with those larger droplets. Smaller particles are created whenever you sneeze or cough or the like, and they can be at such a small size that they form what's called an aerosol, and aerosols can drift in the air for protracted periods of time. Therefore, they can travel further, they can move with air currents, and the length of time that they can travel is somewhat dependent on things like the temperature, the humidity, because as they dry out, they then become, well, not a risk in terms of the COVID virus itself requires a moist surrounding for it to survive. And once it dries out, it is 99.9% ineffective. And in fact, the studies that have looked at where it has dried out, other than very, very rare examples in the lab, it doesn't tend to be an issue. So this diagram gives us a bit of an idea of what we're talking about. I like pictures better than I like words. So the red guy on the left coughs, and as you can imagine, you have large droplets which fall relatively quickly, middle-sized droplets that maybe travel a little bit further. And some of those droplets will land on surfaces, and this is called the fomite route. Others may be directly inhaled by somebody. And that has the potential to infect somebody. The fomite route basically is a wet surface. Somebody comes along and puts their hand on that and then transfers their hand to their mouth or around their eyes, and that could be another route. And then finally, the airborne route, where we have the particles which can travel much greater distances and be buoyant in the air for a period of time. We know actually that the direct route is probably the most common route for people being infected, and that aerosols are probably the second, and actually the fomite route may well be the third or least likely, but all three are known to happen, and therefore the controls we put in place should try and deal with all three. The issue then around ventilation is, why is ventilation important? Well, we need to consider another concept, which is about viral load. So it's unlikely that by one or two aerosol particles, by you breathing those in, that you will develop COVID. You're much more likely to develop COVID if you are exposed to a high viral load. You get the high viral load from larger droplets or multiple aerosol particles. So by diluting the air that contains the aerosol and by removing any particles by moving the air out, freshening the air, or other methods, you reduce the potential viral load and therefore you reduce the likelihood of somebody developing COVID. So the risk from aerosols is therefore greatest in areas which are poorly ventilated. You have somebody constantly coughing and sneezing. There's nowhere for that aerosol to go. It's not being diluted. So the levels of COVID aerosol particles or aerosol particles with COVID in them in a room or in a space increases over time. And the likelihood then is that somebody can catch the virus and develop COVID. I've often been asked, whenever we move towards the importance of ventilation, people will say, well, look, if we get the ventilation right, does that mean you stop doing the other things? And I wanted to say up front that no, it's not. The direct route and fomites still pose a significant hazard of somebody getting COVID. So we still need to ensure that other control measures are in place where there's a significant risk. So we look at the droplet transmission, and that's from people being in close contact with each other, and contact transmission, and that's around cleaning of surfaces and hand washing and cleaning for individuals themselves. So although this presentation is very much around the ventilation side, what I'm saying is it's not in itself sufficient if you wanted to prevent COVID transfer altogether. In light of that, we would still say that you need to ensure that all of the risks are being managed. That's good business practice. So first of all, making sure infected workers or people who have the symptoms and haven't had a negative test don't come into the workplace. There is some talk in GB that isolation associated with positive COVID infections is going to be removed as a control. That will then become up to businesses to decide what they want to do in relation to that. But for the time being, there is a requirement to isolate, and certainly in Northern Ireland, there is a requirement to isolate if you're COVID positive. We are continuing to recommend to businesses that they would ensure that staff who are testing positive or have symptoms are sent home. The general guidance remains, and it is guidance around distancing, social distancing, the use of screens, good hygiene measures, good cleaning measures and the like. And along with that then the provision of adequate ventilation. And deciding on what adequate ventilation looks like in a workplace should be part of a risk assessment. And this initially caused a fair amount of confusion. Up until a few weeks ago, the requirement for the risk assessment was actually under the Health Protection's coronavirus restriction regulations, Northern Ireland, and it wasn't something specific under health and safety regulations. And that surprises some people, but that's the nature of where we are with it. And I'll try and explain that a little bit. And by the way, that regulation has now been removed, so that specific requirement under those regulations for risk assessment no longer exists. So if we look at the health and safety at work field and the management regulations, and you'll all be aware, management regulations talk about the need for employers to carry out risk assessments, both for employees and for persons not in their employment, but arising out of the conduct of the undertaking. And the key bit here is for the purposes of identifying the needs, what somebody needs to do to comply with the requirements and provisions imposed on them by or under the relevant statutory provisions. So what we then must look at are what are the relevant statutory provisions that apply to COVID type issues. And interestingly, well, there are no specific relevant statutory provisions which deal with COVID. There is no specific health and safety law which has been created with a title or specifically dealing with COVID. But clearly some of the other regulations can be applied. So where individuals are working with the organism under COSH biological agents, then there will be a requirement for COSH provisions to be applied. However, for the general working population, the key ones here will be around the workplace regulations. And there are two particular ones here that I think are maybe the most significant. The workplace regulations around ventilation 6.1 and the workplace regulations about sufficient washing facilities and under 21.1. And again, what we'll talk about here today is the risk assessment associated there for under the workplace regs 6.1. So clearly there is a requirement. It's a general requirement around good ventilation, and it applies not only to COVID, but to other matters. But what we're going to look at here is the COVID aspect of that and how that can be used. So in terms of what that looks like, the priority for the risk assessment is to identify any areas which are usually occupied and which are poorly ventilated. And those will need to be then prioritized in terms of what we can do to improve or reduce the risk of the aerosol transmission. A lot of this isn't rocket science, and nor does it have to be, and I'll talk about experience once we've gone through some of this, but there are some pretty simple things that can be done. So looking for areas where people work where there is no mechanical ventilation or natural ventilation. And what I mean by that is either systems which are introducing air mechanically through ducts and air conditioning units and the like, or rooms or spaces where there are no openable windows, doors, or vents. And clearly, in those sorts of situations, you get the position where the ventilation isn't going to be good, or where those vents are being closed and not opened, or, for example, where doors or windows can't be opened. In terms of mechanical systems, what we're looking for in those is a system which introduces fresh air. So if it's, and you come across these, if it's a system which purely recirculates air around, it may do something in terms of heating or cooling and adjusting humidity, but if it's simply moving air around, well, that's not fresh air and it doesn't actually help us at all. So what we're looking for are systems which bring in fresh air. So if it's purely a recirculation system, mechanical system, then that's not going to help, and further action will probably be needed there. Identifying areas that feel stuffy or smell bad, particularly after use. As a health and safety inspector, yeah, we come across them. Again, it's not rocket science to identify some of these. And you know, common sense, small spaces with large populations of staff are most likely to be the difficult areas to deal with. What we have found is larger open spaces, even ones which aren't particularly well ventilated, the levels which we'll talk about later on don't tend to be exceeded. So what are the factors here that are affecting the air quality? Well, ultimately, how many people use and occupy the area. For COVID, if there's very few people in it, then, well, if there's nobody in it, there's no risk other than yourself. And the more people there are, the higher the likelihood is somebody there is maybe an asymptomatic carrier, and the more of them that are producing COVID articles into the aerosol, then the greater the risk. As I say, larger areas tend to be a lower risk. It's not always the case, but in general, that's what we're seeing. The tasks and activities which take place in the area, so things which result in people breathing deeper, physical exertion, shouting, and interestingly, singing. One of the earliest examples of the aerosol transfer was an outbreak that happened in America and was associated with a choir practice, and it was identified through that. So things like singing, that will increase the risk because people are more likely to be producing aerosol. Also, things which cause more exertion means that people also are more likely to breathing in more deeply, and therefore increased respiration rate will increase the risk to the recipient as well. Features of the workplace that affect it. So sometimes you will get areas which are perfectly good, and then you'll go into a small dead end area, and you can get areas where there's stagnant air. Air is not moving well through that, and in those sorts of situations, again, that can affect it. Equipment may affect the air quality in terms of both positive and negative. And so, for example, if there's local exhaust ventilation as part of a process, that usually improves air quality standards. But simply sticking a couple of fans in an area and moving air around within an enclosed space will not. And in some industrial situations, we come across the ventilation systems, by the nature of the environment that has to be maintained, can be very, very complicated. And in those in those cases, you really are looking at professionals to come and look at it. But as I say, for the majority of cases, this is relatively simple and sort of straightforward stuff. Where you do have more complicated scenarios, or where there's a significant degree of concern, there are a few things which can be used to assist. There are a number of tools. Probably the best one that I have seen is the British Occupational Health Society's assessment tool. And I have some web links at the end here. That, along with the potential use of CO2 monitors, and I'll cover those in more detail, and then the use of specialist heating and ventilation engineers. That one is for the complicated systems, because there are so many factors in those big complicated systems that often it needs a professional to be able to look at them and understand their operation, and therefore how to control them to reduce the risk. So the BOHS assessment tool, I'll point out that it's available. It's relatively simple and straightforward. It asks questions like the floor space, the height, how many people are using the room, in what circumstances. It asks about what ventilation is available in the room. And again, they're relatively simple questions. And then it comes out with a scoring system of, I think it's high, medium, and low risk, and with options, things that can be done to reduce the risk. And it can be quite useful too in terms of being able to assess, well, if I've got a room where there's a problem and I do X, will that improve it significantly? So that assessment tool, it's an online tool, relatively simple and straightforward to do. And for those situations where people are finding it hard to make an assessment, that can be quite useful. The use of CO2 monitors, I think that's reasonably widely known now as one potential way of looking at risk assessment. You have to be a little bit careful with it and understand how it works, but it certainly has been particularly useful for us, because as inspectors, it allows us to go in and make very rapid assessments. Now, a one-off by itself is not sufficient, and I'll explain that in a little bit of detail, but it does allow us to make an initial assessment. There are both handheld CO2 monitors where you just make single or measurements, and there are also more complicated devices which can remain in an area and constantly monitor CO2, and in fact can alarm if CO2 levels are rising, for example. Both types of system have their pros and cons, but both are equally effective. So how does the CO2 meter system work in terms of risk assessment? It doesn't actually measure the aerosols or the amount of COVID in the air. What it does do is, as we breathe out, we all expel CO2, and therefore it indicates how much CO2 is in the air. And that's a proxy for the ventilation, the quality of air in the room, and also a proxy for how much you're likely to see aerosols in that space. So although it's not a direct measure, studies have shown that it's actually a very good proxy, and that it can be used therefore to assess CO2. And it was used before COVID ever came along. There are certain air conditioning systems, for example, which are controlled not only in relation to heat and humidity, but also use CO2 to give optimal air quality whilst maintaining efficiency of a system. So it's tried and tested technology, and it's turned out to be very useful in terms of assessment for COVID risk assessment purposes. There are many different types of CO2 monitors available, and they range from things that one can buy on the internet for a few pounds, of which I would probably avoid, up to very, very expensive meters in the thousands and thousands of pounds. And again, I don't think for the vast majority of cases that's needed. What we're normally looking at here are devices called NDIR, non-dispersive infrared CO2 monitors. It's the best technology, the least likely to be affected by extraneous issues, and in terms of cost are usually in the sort of 80 to 200 pound bracket. So again, not particularly expensive. So the use of the CO2 monitor, now this is somewhere where we have seen problems, is that there's been some confusion. So where you take the measurements and when can have an effect on the numbers that are seen. The levels vary within an indoor space. They vary over the day, they vary depending on occupancy, and they can vary quite significantly depending on where you take that measurement. We would say the best place to take the measurement is at head height of the people. So if people are standing at standing head height, or if it's an environment where people generally sit at sitting head height, you do it away from open windows, doors, and the like, because all you will be doing in that case is measuring the fresh air content. And what you want to measure is the average ambient air content. And likewise, you don't want to take a measurement within 50 centimeters of somebody's head, because you will get a false high reading from being adjacent to somebody who's breathing out CO2. We've also seen some cases where we have detected, or businesses have detected, very, very high levels of CO2. And there has been a panic only to find out that it's associated with production equipment, because some production equipment will produce CO2, not to levels that are dangerous, but certainly higher than the levels that we use to assess air quality. So, for example, heating systems, some inert packaging systems and the like, there's CO2 associated with those, and you can't use a meter in those environments. I always tend to, if I'm using them, I tend to take a couple of measurements outside before I go in, just to check that the levels are what I would expect to see. And outdoor air, you can expect anything from around 500 parts, certainly in Northern Ireland, what I've seen, 500 parts per million, up to 700 parts per million. And if you don't get those outside, then you'd have to consider your meter. Is there an issue with the meter? Most meters will come with instructions about calibration, and actually most are reasonably resistant to errors like that. Equally as well, if you come up with very, very high levels, then I would repeat measurements just to check in case there's something wrong in terms of the monitor or the location you're taking it. And finally, snapshot CO2 readings can be a bit misleading. I've come across a business who said, oh yes, we went into the changing rooms, took measurements, and the levels are in and around 600 parts per million, therefore we're okay. That was pre-shift, after a night when there'd been no one in the room. If they had taken the measurements at the point of time just after the changing rooms had been used, they would have seen the levels were up in the 9 to 1100 area, and therefore indicated that whilst it wasn't drastic, that the ventilation could be improved in that area. So we tend to say that you're better to take a number of measurements over the period of a day during normal occupancy, and that will give you more accurate results and a better feel for what you're dealing with. So what do the numbers really mean? The CO2 measurements, they tend to report back in parts per million. And as I said, outdoor air, I tend to see around 600 parts per million. And indoors, what we would call high quality air, well ventilated spaces, 700 to 750, in fact, up to 850, generally very good, to be honest. Those sorts of levels, I don't have any particular. Where you get above 1,000, then I would say we're into what we would call moderate air quality, and 1,000 to up to about 1,500. In those cases, then you're saying to businesses, can you improve the air quality here? Can you look at ways to improve that? And we can talk about what they might do. And cases which are above 1,500 parts per million generally indicate that there is an issue there that needs to be addressed quickly. And that can be done again by a number of reasons. Where we have seen those, to be honest, it's blatantly obvious that there's going to be a problem. It's very small spaces with a lot of people in it, or the only times that I've come across levels like that, or where you have a rather complex recirculation system which hasn't had enough fresh air introduced into it. So those are the sorts of levels that you will see, and depending on what you're getting, it may well be that there is no great need to do an awful lot other than maintain the ventilation that exists already. And quite often we'll go into businesses and look, and the values are well below the 1,000 in the majority of places. But where you are starting to see things deteriorate, where the values are higher, it's simple things like improving the natural ventilation by opening doors and windows and the like that make a big difference. It says about fully or partially opening doors and windows and the like. My experience of the sites that I visited for office spaces, changing room spaces, toilets and the like, they didn't need anything like fully open. It was just enough windows opened a bit, doors cracked open that allowed sufficient ventilation to get the values down. If you are opening doors, make sure it's not fire doors. That's a given. Fire doors are there for a purpose. And the risk from a fire spreading through a building is going to be greater than the risks from COVID, or certainly the current COVID variants. Most buildings, and this is a general comment, most buildings are designed to provide adequate ventilation. I can think of lots that aren't. But you should be able to open windows and vents and the like to let in fresh air. Most of them are designed to allow, if you can't open windows, to have vents or some other system. We all know that some buildings evolve over time and windows can't be opened and then painted over and all sorts of things. So that's not always the case. But the designs of buildings should allow for effective ventilation. One of the common ones that I have seen is a shared office space with 2 or 3 people, and it's a small space and the windows and doors are closed completely. And those do relatively quickly, because they're small and multiple occupancy, develop high levels of CO2, and therefore what we would say is the ventilation is poor and the risk is higher. So closing windows and doors completely where there is a small space is not good news. Some instances we've come across things like there are ventilators, louvers, air bricks and the like, and they have been not maintained, or people have complained about a draft and stuck tape and paper over them and things like that, and that has created a problem. So we encourage fresh air, things like trickle vents, grids and ventilators, that businesses would check them and make sure that they are able to flow air freely. I know, and I'll talk a little bit about thermal comfort, but in cooler, windier weather, people say, oh, we can't have windows open, we can't have doors open. In those conditions, you don't need the doors and windows open as much, because naturally there is a greater pressures created around the building, and therefore the airflow increases naturally. So you can afford to ease back a little bit in those sorts of conditions. Very still weather, warmer weather tends to be the times when the ventilation rates are poor, and therefore you need to consider making sure that the windows and doors are open that little bit more. So the worst sort of scenario will tend to be middle of winter, very cold, still morning. And in those situations, you have a combination of cold air and poor ventilation that can be more difficult to manage. And an important one here is airing of rooms, and we've seen this working very effectively. Periodically opening doors and windows fully and allowing the room to air a bit can significantly reduce the levels, and then it takes, certainly for slightly larger spaces, takes some time for the levels of CO2 to increase again. So by repeating that throughout a day, and then using a CO2 monitor, you can soon judge what is effective in terms of regular purging or just airing a room out, as I like to call it. And that does actually work quite well. There was a lot of talk some time ago about air cleaning and filtration units, and money has been spent by businesses on them, and they have been put in place. You can use them. The better units will reduce the amount of particulate matter in the air, including aerosols. They tend to work either using high efficiency filters, which literally prevent or catch and prevent the aerosols from coming back out of the system. And there's another set that use ultraviolet light, which neutralizes a virus if it's present within the air. First off, look, these are not a substitution for good ventilation. They might have to be used in certain circumstances where you've got a poorly ventilated area and you can't find any other way around it. I'm not overly keen on them, to be honest, for a number of reasons. One is that there are very few good standards that exist, and lots of these units have been made, and it's difficult to stand over how effective they are. The second one is that they require maintenance, and they require energy, and they require to be placed in the proper place and kept in the proper place. And therefore, they have a tendency to fail to danger if they're not in the right place, if they're not maintained, if they're turned off. And we've seen this too, you know, somebody accidentally turns the thing off, then they're not doing what they need to do. And it's more difficult to make an assessment as to whether they're being effective because you can't use CO2 to assess the air quality where these are being used because the CO2, they have no effect on the CO2 levels in the room. So they have their place in some instances, but I would always recommend people look for good ventilation in the first instance and would consider these only where you can't achieve good ventilation by other means. For mechanical systems, mechanical ventilation systems, which we see, so that's the air conditioning units, mechanical air handling units and the like, you see grills and louvers and ceilings and walls quite often, or air conditioning units on the wall. It's slightly more complicated. However, I think the key thing to remember here is about fresh air. So those systems which can be switched to fully fresh air or predominantly fresh air, and they're bringing in air, they're conditioning that air, whether that's heating it or simply moving it in or carrying out other functions to it, but are inputting fresh air are good. And some systems actually can be adjusted so that there is more fresh air introduced. Some of them use a certain amount of recirculation. And again, in a controlled way, with the use of CO2 monitors and the like, that may be fair enough, but fresh air is the key in this. What is not particularly good are units which simply recirculate the air in the room and air condition that air. Sometimes you'll see a wall-mounted unit and it has got an air intake and then a set of louvers and an air output side of it. And all they're doing is moving the air around. So you can imagine it has no effect other than to further distributing the aerosols. So we don't recommend those. There are a few which will use combined fresh air from outside and recirculated air, and will use automatic systems like a CO2 level system automatically to balance that and give you effective fresh air ventilation. They tend to be the more complex system. I've seen them in a couple of more modern schools and in a couple of more modern offices, and they are acceptable. And I think that this isn't a straightforward issue, and for the more complex systems, they may well require professional input in terms of ensuring that they're operating effectively. But most of these systems are in facilities where there will be service engineers and service companies who can provide that. A couple of practical solutions, because quite often it's the simple stuff that seems to work, and this is from what we have seen, I've seen on the ground. So I was asked to have a look at an office scenario, and there was a couple of different sort of things that we saw in that office. So one, opening in windows and doors in an open plan area of an office at the 2 tea breaks. They had a tea break in the morning, tea break in the afternoon, and then a lunch break. So the people tended to be out of the room, so they literally opened all the doors and windows during that period of time. And over the day, they had constant CO2 monitoring. And at the start of the day, the CO2 would start to come up from the 700 levels and rise towards 900 or 950. And then at the tea break for 15 minutes, all the doors and windows were opened and it brought it back down to 700. And the same happened throughout the day. So they were able to use a simple purging technique. And it meant then that they didn't have to have the windows and doors open at all times into the office, and the use of a constant monitoring CO2 unit, which was relatively cheap, allowed them to operate that space safely. The same area had some managers' offices and interview offices, and in that case, it was a small office area for 2 people. When I went in and sat in it for 15 minutes with the monitor, the CO2 levels for me went up to above 1200 by just me sitting in the room with no ventilation. And we had looked at a similar test for 2 people in the room, and in that case, within 7 minutes of opening the door and cracking open the window a bit, the levels had reduced from 14 to 800 parts per million. So those are very simple measures and shows the effectiveness of the a simple approach in relation to this. A factory that we dealt with associated with an outbreak had refrigerated air systems. They increased the amount of external fresh air into the system by 30%, and that reduced some of the CO2 levels in areas in the factory from above 1600 down to less than 800. And then they were able to fine tune that. That was earlier on in the pandemic. And then another case where a business had an area that was, I think the issue here was it was a long corridor with a number of rooms off either side where packing and storage was going on. And the problem was the air wasn't, fresh air wasn't even though it was available in the main factory, wasn't getting into this. And they brought in a portable air handling unit that brought fresh air, and that's the key thing here, into that area and brought it down to the far end. And then that air then permeated that whole corridor and storage area. And again, they saw a very significant improvement in terms of the air quality in those areas without affecting either significantly affecting temperature or the activities that were going on. Sometimes these air handling units can be a bit noisy, so where they are placed can be important to ensure that they don't create additional risks associated with noise. Quite often, one of the problems, and we saw this earlier on in the year when we were starting to push on ventilation, is keeping people warm at work. COVID probably will not be such a big issue in the summer, and we saw this over last summer. In better weather, for lots of reasons, the transmission rates tend to drop. But in cold weather, it can be quite difficult, and balancing good ventilation and keeping people warm is going to be an issue regardless. And all we have asked here is that people consider doing some simple stuff. Certainly, people shouldn't end up in uncomfortably cold conditions in the workplace. And we should be able to manage drafts as well, which is a common complaint. So again, it's not always about throwing every door and every window fully open and having a howling gale. That may be well in excess of what's actually required to keep the air safe. So partially opening windows and doors can provide better ventilation whilst keeping temperatures comfortable. In general, you're better if you have got the choice of opening higher and lower level windows. High level windows, it allows warm air which is traveling from ground level upwards to mix with the cooler air. If you open the lower level windows, which tends to happen is the lower level, the air doesn't mix as well and the cold air fills in at floor and leg level, and we all know that can be uncomfortable. So higher level windows where possible. That was particularly effective in some of the schools I visited. And in rooms which are relying on natural ventilation, then when the room is unoccupied, if there are opportunities to purge the room, as I've discussed before, to air the room out, again, that can be significant as it drops the levels way down to atmospheric again, and it may take some time for those levels to increase. So purging can be a really useful one. We've said things like, dress code, and again, I've seen this in a number of places, allowing staff to wear an extra layer or layers can make a significant difference. Increasing temperature on heating systems to maintain a comfortable temperature. It's not always fully effective because of the fact that some heating systems just can't manage it. But generally, it can help the problems that we see. Consider additional sources of heating. The one just to watch there is fan convector heaters. Should only be used if it is in a well-ventilated area. If you're in a mediocre area, you don't really want to do that because you may be pushing some of the aerosol around, and that's not ideal. I've thought of something else there that isn't in the points, but I promptly managed to forget it. But if it comes to me, I'll pick it up again. And sources of information then. A year or so ago, it was nearly impossible to get any useful information to help us decide on what was appropriate. And we had everything from do nothing through to hugely expensive systems being suggested, and requirements for tens of thousands of air purification units to be provided and the like. The answer lies somewhere in between. A lot of this is practical common sense and being aware of what the issues are and being able to address them. There is further information. HSEGB's website has got a section around coronavirus and ventilation. There is specific Northern Ireland guidance available on the NI Business Info website. And again, that is closely aligned to what you'll see on HSEGB's site. The tool that I talked about, the ventilation tool, again, is freely available through BOHS's Breathe Freely website. The Breathe Freely website has a number of resources, not only around COVID, but around other issues associated with lung diseases and ventilation and the like, and can be quite useful. The Chartered Institute of Building Service Engineers, CIBSE, probably were one of the first to get useful material out, and they have a number of documents on their website which are freely downloadable, which talk in more detail about ventilation and solutions for the more complex ventilation systems. I think that's the end of my slides. And hopefully that has been a bit whistle stop, but hopefully that has been useful. And I think maybe then if there's questions.
Bryan, thank you so much. That has been really helpful and very informative. Thank you indeed. We do have a wee bit of time until